So first off, I want to welcome Jordi to the stage to tell us all about Circom. Please take it away, Jordi.
Okay, thank you, Anna. Well, first of all, congratulate Alex, because I think he did a very good job just explaining all this ecosystem of languages. I'm going to talk about Circom. Circom, well, like any language, I like to start like a kind of hello world. Here we don't have a real hello world. So hello world would be just a multiplication. It's a very simple circuit. As you know, a simple circuit is just a deterministic circuit. You have inputs, outputs, and you get always the same result. And here is where you construct the proof that you have, the inputs, and the inputs that builds these outputs without revealing the inputs. This is mainly what zero knowledge about. So here is a hello world. You see here we define two inputs, A and B. We define an output, C, and then we just assign C to AB. And then we just instantiate this template, this multiplier as a main, and that's it. We have the circuit. So this is the first property of Circom. Circom is very easy to write. As you can see, well, this program is not good. Is because we are working with fields, and to just what we really want is to, for example, now if we are able to do a factorization, this circuit is quite obvious because you can factorize very easy in the field. It's not like a normal it's not like a normal integer in the integral fields. That's much easier. It's much more difficult. If you want to get some more complex, maybe one thing that you can do is, for example, check that A and B have a number of bits. Okay, so here is like, let me say, a more complex. This would be a more complex circuit that mainly has two blocks. Okay, two objects. As Alex explained it, Circom is an HDL, so you build like hardware. So you have like microchips, and then you just connect them all together, and with one microchip you get another bigger and big one. So in this example, we have check bits. Actually, is you get an input, and then you check that this input has exactly 16 bits. I'm going to step a little forward just to move forward, but you can write it easily in Circom. And at the end, we just instantiate two of them and then assign the A and B to these inputs, and then just build the output. So here we have a circuit, a very simple circuit that actually proves that to factorize 128 bits number into 64 bits. Okay, so this is just an example. Because just to explain clearly, is when you are building a zero knowledge, what's the flow? What are you building? Okay, and this is very important because I think this is very different in many languages in libraries. Okay, but the output, so the input of the circuit, of course, is a Circom, is the language. But what's the output? What's the executable? Okay, so in Circom, the output are two things. One is the constraint system. This is my circuit R1CS. Actually, all the intermediary. All these intermediary, so the circuit, all these intermediary signals, how they relate to each other. So this is one output, which is an array, if you want, a matrix of constraints. Okay, and the other thing that's important is witness calculation. Is how do you, at the end, is a program, and this is very important to understand. Circom is a language that one of the outputs is a program. This program, it can be a WASM, and will be a CPP, and in the future can be other language. But right now, we are able to build the WASM and CPP. And this program that generated by Circom, actually what it does, it takes an input, and it computes all intermediary signals on the output. So it computes all the witness. Okay, so the output of the circuit is this input and R1CS. And here is when the R1CS is what we plug when we plug in growth 16, or we plug in Plonk, and we just create a setup, trusted or not trusted, depending on the primitive, the cryptography primitive that we want to use. Generates a prover key, we generate a verification key, and then the normal process goes from left to right. You get an input, you calculate the witness. With the witness, you calculate the proof, and this proof is verified. And of course, this proof is verified according to this proof matches these public inputs and outputs, matches this JSON. So this is the main flow. But it's very important to understand that Circom actually generates C++ and WASM. It generates it very efficiently, especially in the C++. The code that generates, it runs in parallel. It's using a finite field that's very optimistic, optimal, and it's Actually, we are generating circuits of 128 million constraints to the 27 constraints, and a code. We're generating a code that's building that, and it's computing all this witness in very few seconds. 2, 3, 4 seconds, because it does it in parallel. Okay. Just properties. Circom is very useful. It's very used in the academic because it's very easy to it's very, the entry level and the learning curve is very fast. So here are a lot of courses, online courses, and universities and people. It's very useful for explaining, and you can do the tutorial in Circom and it will take you less than 1 hour, and it's absolutely worth it because you understand how this works, and this is very easy for the academic. But actually, the Circom, the important thing is that it's running in production. All these projects, in some way or the other, are doing that in some production environment. I want to highlight Tornado. For example, Tornado Cache is using that. This was one of the first projects that actually was using and is using Circom. It's been running for a while. Of course, Hermez Rollup is built fully on Circom. All the circuits that are running in Hermez are in Circom, and then there is an important set of projects that are using that Forest as a game, Bognoni for voting, another rollups, optimistic zk rollups, even 3 from identity. So there are many different projects that are using this, and this is important that Circom is. If you see in the list, it's a quite. Circom was the first version was in 2017, I think, or something like that. So in this while has been very mature on that. Circom goes together with a library. It's like it's a library that's written in Circom itself. So there is not a special library writing in something else. It's a set of circuits that are already implemented that implements that already have some primitive, cryptographic and non-cryptographic. But here, for example, we can do an SHA-256, we can do a Poseidon hash, we can do a MIMC, we can do Merkle trees, we can do EDDSA signatures, we can do all sort of jabs or elliptic curve operations inside the curve. We have also Boolean operations, so we have a conversion to binary to not binary. So we have all the basic functions are in Circomlib. It's a library it's growing, and I hope in the next month even will be much. It will grow much more. That's an important part of. Well, it's not go together because it's just a library. Anybody can write a library, but well, it's a good starting point, and it's a set of tools that you would need when you're building a circuit. Okay, and I also want to mention that there are some pieces outside Circom that plugs very good. These are the engines of the engines. Here also I want to highlight Snark.js. Snark.js is a JavaScript. It's a JavaScript library of Snarks. Actually implements Growth 16, and well, I have not merged it yet, but in a few days it will be available. It will be available also in Plonk, basic Plonk. So you just write the circuits and you can run it that, for example, in the browser. Okay. And another important project is Rapid Snark. That's mainly a fast prover. At this point is for Growth 16, but it's a prover that runs in parallel in a very efficient way. And as a reference, for example, we in Hermez, we are computing proofs of 128 million constraints in a minute or less than a minute. Okay. 2 words about licensing. Licensing is Circom is GPL 3 for the Circom altogether. I think that if you are doing anything in cryptography, you should do open source. If you are not doing that, but maybe you have other problems. And for the runtime, it's Apache. So if you are building some special projects and you don't feel comfortable with CPL, you can still use Circom, because the one thing is Circom, the language, the other thing is the code so the result that the language generates. So the runtime part of the Circom, you can run it in whatever license you want. So you are not tied to the GPL restrictions. Okay, a little bit about the future. We are finishing very close. We are reviewing the fully rewrite of Circom, absolutely rewritten in Rust. This has a lot of advantages. First, because Rust is much faster than JavaScript, as you can imagine. It's much more better written. It's secondary write. And the most important thing on my side is that this is, for example, auditing those languages is quite complex. But so writing the language 2 times for independent people, even in different independent approach, and just comparing the results and comparing how it works together, this is a very, 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 very good way of testing that the language actually do what it has to do. Okay. Another things that we are thinking, and I hope that we can implement very soon, is, for example, custom gates for Plonk, and this is something that we will start to work very soon on that. And also, for example, things about typing and especially just you don't mess up. It's very much like a signal. So like in hardware, when you connect different voltage signals and you do a shortcut, this is very much a kind of thing that you can do with this HDL language. You know, it's just checking that the signals are quite good or not. Okay. For accessing Circom, I would just put here 2 links. One is Circom itself, is the GitHub repository. You can go there. You can find the tutorials and so on. And the other thing is the community. There's the Telegram channel. There is a very nice community there. Many people that's using Circom there. So if you start using Circom or you just connect there, and there is a very nice people there. Can ask questions on Circom,